Ladies and gentlemen, welcome. Today, we are on the second chapter, Frequency Distribution and Graphs. This is the support class for your Introduction to Statistics Math 135, which is called the Quantitative Literacy Math 092. The big goal of this course are demonstrate proficiency in prerequisite skills for Math 135, Introduction to Statistics. Meaning of that is here we are looking at some basic skills that you need in order to perform well in Math 135. Demonstrate improvement in requisite skill in Math 135, Intro to Statistics. That is here we are learning the skill that will help you improve the skills required in your Math 135 class. And the third thing that we'll do in this course is develop the study skill as they relate to 135 Introduction to Statistics. So we'll discuss or we'll briefly go over the skills that you need in order to be successful in Math 135 Introduction to Statistics class. First, the fundamental skills required for this class. So for this week, I've listed these skills so that you'll be aware of what skills or what you need to do this week. Make sure you stick with the schedule and don't fall behind. Meaning of that is complete all assignment on time. You can take advantage of the office hour that is set for you. Tuesdays and Thursdays, 9 a.m. through 11 a.m. and Monday through Thursday, 9 p.m. through 9:30 p.m. by appointment. Also, make sure you attend the live Zoom classes where I will be teaching Math 135 Monday and Wednesday, 9 a.m. through 11 a.m. One of the best ways to learn mathematics is through groups or group study. So try to email your friends using the class list in D12 and make a study group and help each other. Now we are going to begin with the examples for this week. And here is our first example. It says, compute the cumulative frequency for each interval in the table. Then organize the table using the cumulative frequency in place of original frequency. So here we have the class. And for each of these class, they have given the frequency. Now we need to have the cumulative frequency. So what I'm going to do is I'm going to add a third column here, and then we are going to find the cumulative frequency. Cumulative frequency is the frequency of the class equal to and less than that. So for example, for this one, the cumulative frequency is equal to 8. For the second class, it is equal to the frequency of this class plus all the frequencies below that. So it will be 40 plus 8, 48. Notice that we obtain 48 by adding 8 and 40. Now, cumulative frequency for this class is the frequency of this class plus all the frequencies below that. So it is 16 plus 40 plus 8, which is equal to 64. Also notice that you can obtain this 64 by adding 48 and 16. So you can follow that pattern now. 64 plus 6, that will be 70 for next class. Then 70 plus 4, so 74 for this class. Then 74 plus 3, 77 for next class. Then 77 plus 2, 79 for that class. And then for the last class, it is 79 plus 1, which is 80. That means the total number of observations here is equal to 80. So this is how we can find the cumulative frequency. Now in next example, we are going to use the same data to find some additional information for this frequency table. Here is the second example with the same set of data, and we are asked to find the relative frequency, and we have to find the relative frequency in decimal form. Then we have to change that to percentage value. So we need the column for relative frequency in decimal, then percentage value, Okay. And then we are also asked to find the cumulative relative frequency. That is the cumulative frequency using the relative frequencies. Let's see how we can do that. First, I'm going to extend this table for all these columns required. Then we are going to perform the calculation. Okay, now our table is ready. I copied the cumulative frequency from the previous example. Now we are asked to find the relative frequency, and relative frequency is frequency divided by n. Here we have the frequency. We have to divide each of these by n, or the total number of observation. So for example, the first one is 8. 8 divided by the total, that is 8 divided by 80 is 0.1. Next is 40. 40 divided by 80 is 0.5. Next we have 16. So 16 divided by 80 is 0.2. Next we have 6. And 6 divided by 80 is 0.075. Next we have 4. And 4 divided by 80 is 0.05. Next is 3. And 3 divided by 80 is 0.0375. Next is 2. 2 divided by 80 is 0.025. And the last one is 1. 1 divided by 80 is 0.0125. So those are the relative frequencies. That's what we are asked to find first. And then after that, we are asked to find the relative frequency as decimal. That is done. The other thing we are asked to find is the percentage values for those relative frequencies in decimal. That means in order to find the percentage for these values, you have to multiply these values or relative frequency by 100. So if you multiply relative frequency by 100, you'll be able to find the percentage for each of these. So first one, we have 0.1. 0.1 times 100, that is 10%. Next, we have 0.5. 0.5 times 100, that is 50%. Next, we have 0.2 times 100, that will be 20%. Next, we have 0.075. If we multiply by 100, that is 7.5%. Next, we have 0.05 times 100, that is equal to 5%. Next is 0.0375. If we multiply by 100, that is 3.75. 3.75%. Next, we have 0.025. If we multiply by 100, we get 2.5%. Next, we have 0.0125. If we multiply this by 100, we get 1.25%. 1.25%. So these values are the relative frequencies as percentage. Next, we are asked to find the cumulative relative frequency. So when we find the relative frequency, we divided frequency by n. Similarly, when we calculate cumulative relative frequency, we have to divide the cumulative frequency by n. So these are the cumulative frequencies, and we are going to divide by n, or the total, that is equal to 80. So for example, the first one is 8. 8 divided by 80 is 0.1. The next we have 48. 48 divided by 80 is 0.6. Next we have 64. 64 divided by 80 is 0.8. Next is 70. 70 divided by 80 is 0.875. We are dividing by 80 throughout. Next is 74. 74 divided by 80 is 0.925. Next is 77 divided by 80, which is 0.9625. Next one is 79 divided by 80, which is 0.9875. And the last one is 80 divided by 80, which is 1. Okay, so that is the end of our second example here. Now we are going to go to the third example. Here is the third example. The given group data, or the given grouped frequency table, represents the number of minutes 60 shoppers spend online shopping a week. So here is the information given to you. In the first column, you have the interval, that is number of minutes shopping online, 0 through 10.4 minutes, 10.5 through 20.9 minutes, and so on. And here we have the frequency. What we are asked to do is, we are asked to find the class midpoint. That is, we have to find the midpoint of each class here. So in order to find the midpoint of the class, what we need to do is, first, we need to make this class uniform or continuous. You can see here is 10.4, and here we are starting at 10.5. Here is 20.9, and here we are starting at 20.9, so we have 21. And then here we have 34.1, then 31.5. So we are jumping by 0.1. So meaning of that is, for example, when you go from 10.4 through 10.5, the difference or the jump that we have here, let me write jump between class, jump between classes, is equal to 0.1. Now, in order to make the class continuous, what we do is, we divide this value, the jump between classes, by 2. So let's divide that by 2, divide here by 2, divide here by 2. So it will be 0.05. So what we do is, to all these lower limits, we subtract 0.05, and to all these upper limits, we add 0.05, and we make the class continuous first by keeping the frequency same. So let me draw that table here. So here we have this adjusted class, which we obtained by subtracting 0.05 from all the lower limits and by adding 0.05 to all the upper limits. We have the same frequency. Now we need the class midpoint. And in order to obtain the midpoint, we have to add the lower limit and upper limit of the adjusted class and divide it by 2. For example, here we are going to add negative 0.05 and 10.45 and divide that result by 2, which we get 5.2. Next, 10.45 plus 20.95 and divide that sum by 2 and we get 15.7. And here we have 20.95 plus 31.45, divide the sum by 2 and we get 26.2. These are the class midpoints. And here 31.45 plus 41.95, divide that sum by 2 and we get 36.7. Next is 41.95 plus 52.45 and divide that sum by 2 and we get the result 47.2. That is the class midpoint. Next we have 52.45 plus 62.95 and divide that sum by 2. You should get 57.7 as the class midpoint. And for the last class, 62.95 plus 73.45 and divide that sum by 2 and the result is 68.2. So these are the class midpoint. So always remember, in order to find the class midpoint, we add the lower limit of the class and the upper limit of the class, and we divide this sum after we add, and when we get the result, the sum, we divide that sum by 2 and we obtain all these values. So that is what is asked in this third example. Now we are going to move on to fourth example. Here is the fourth example. And here we are asked to interpret the data given in this pie chart. So if you look at the pie chart, you can see here, they say chocolate 29%. Here you can say, so these are the ice cream flavors. Chocolate ice cream, 29%. Vanilla ice cream, 39%. Strawberry, 11%. Coffee, 15%. And other flavors, 6%. The pie chart is given. We need to interpret this. So the way you interpret may be different from what I'm going to do. It's going to be different, but what I'm going to do is, I can see that this area is maximum. Okay, this covers most of the pie chart. this is maximum compared to the other flavors. So we can say that the most popular ice cream flavor is vanilla. So that could be my interpretation. So that is my interpretation. The most popular ice cream flavor is vanilla. So that is the interpretation for this one. Let's go to next example now. Here is the other example. Interpret the data from the given frequency table. Here we have the number of minutes shopping online and then the number of people. So for example, 31 to 41.9 minutes, 8 people, 63 to 73.4, 2 people, and so on. So the data is given here and we are asked to interpret this. So the interpretation may be different from individual, but the way I'm going to interpret here is the number of people who take must here, like 19. So meaning of that is most people spend somewhere between 10.5 to 20.9 minutes shopping online. So that could be my interpretation. You can also interpret using this one, and you can say that these people shop fast. One, not fast, but you can say one of them take 52.5 to 62.9 minutes to shop online. But I am going to interpret with the highest frequency. So yes, most people spend somewhere between 10.5 to 20.9 minutes shopping online. So that is our fifth example. We'll do one more example in this video. So here is the last example for this video. And the question is, interpret the data from the given bar graph. So they have given the bar graph here, and we are asked to interpret the data. Okay, we are asked to interpret the data. Now, let's see what is given here. In this bar graph, if you look at this bar graph, you can see that on Thursday, this is the weekday television viewing. On Thursday, we say that there is most viewing of the television, or they watch the most. So my interpretation could be Thursday is the day with highest television viewing. So that is my interpretation. Thursday is the day with the highest television viewing. So this is the last example for this chapter. Thank you for watching this today. Have a wonderful day.